Hello again. In the previous lesson, we connected polynomial zeros, multiplicities, graph behavior. In this lesson, we'll divide polynomials and use two important rules. Those two rules are called remainder theorem and the factor theorem. Remainder theorem and factor theorem. So let's begin with the quick rules. First of all, synthetic division works for divisors in the form of x minus c. Remainder theorem divides by x minus c with the remainder of f as a function of c. And also, let's see, the factor theorem, x minus c is a factor exactly when f of c is equal to 0. So the key idea is if we know a 0, we can use synthetic division to reduce the polynomial and then factor it further. And let's demonstrate that. So the first example is f of x equals x cubed minus 4x squared minus 7x plus 10. So and it says divide by x minus 5 using synthetic division. Um, State the quotient and remainder. So the divisor is x minus 5. So c is equal to 5, right? Since the divisor is x minus 5, c is equal to 5. And we have coefficients. So I don't have to write this continually. I may abbreviate it in the future. So we have coefficients of 1, -4, -7, and 10. Okay. Now, let's set up synthetic division. Okay. First of all, let's bring down the first coefficient, which is 1. So the first thing we need to do is we're going to multiply 5 times 1. Okay. Now we need to add -4 and 5. Then we're going to multiply 5 times 1. And then we're going to add -7 and 5. Now multiply 5 times -2. And then we're going to add 10 and -10. So the bottom row is 1, 1, -2, 0. Okay. The last number is the remainder. So the remainder is 0. The other numbers are the coefficients. So since we divide a cubic by a linear factor, the quotient is quadratic. So essentially the quotient x squared plus x minus 2 with the remainder of 0. So f of x divided by x minus 5 equals x squared plus x minus 2 because the remainder is 0. Essentially, because the remainder is 0, x minus 5 is a factor of f of x. Okay. Example number 2. Use the remainder theorem to find the remainder when f of x is equal to this expression that's being divided by x plus 2. So the remainder theorem says that when we divide by x minus c, the remainder is f of c. So here the divisor is x plus 2. So we want to rewrite that as x plus 2 is equal to x minus a negative 2. So that we can identify that c is equal to negative 2. Now we're going to use the function at negative 2. Negative 2 is 3, negative 2 squared plus 4, negative minus 9. So we need to simplify this very carefully. So we know that this is going to be negative 2 times negative 2 times negative 2, or 2 times negative 8 minus negative 2 times negative 2, positive 4, then minus 12, final result, 45. Okay, so the remainder is negative 45. Okay. All right, pause the video and try the problem at the bottom. Okay, using the factor theorem, determine whether x minus 3 is a factor of the expression given. So this is what we're going to do. First of all, we know the divisor is x minus 3. So since the divisor is x minus 3, that means that c is equal to 3. So all we have to do is evaluate the function there. So minus 6 squared plus 11, 6. Okay. When we compute this, we obviously need to be very careful. This would be 27. That's 9. That'll be 54 plus 33 minus 6. Okay. Compute this further, we'll end up with 3. So since f of 3 is equal to 0, the factor theorem tells us that x minus 3 is a factor. So yes, x minus 3 is a factor. Okay. So in the event that it end up with a 0, then the expression x minus 3 will be a factor in this case. All right, let's continue. Okay, so given the function that we see here and 1, 0, which is x equals 1, use synthetic division factor. So using synthetic division, we know that x equals to 1 is a 0. Okay, so this is a 0, which means that that is essentially x minus 1. So we know that x minus 1 is going to give us c equals 1. Okay, so c equals 1, and then we have coefficients of 1, negative 2, 5, and 6. Okay, we have coefficients of 1, negative 2, 5. So we want to bring down the first coefficient, which is 1. We're going to multiply and add. So first of all, 1 times 1, 1. Negative 2, I'm just moving along, negative 2, plus that 1, negative 1. We have negative 1 times 1, or excuse me, I should have wrote 1. Like I'll do that. So 1 times -1 down -1. Then -5 actually. -5 plus -1. Gonna give then we have 1 multiplied by -6. We have -6 plus 6, 0. So notice the sequence. 1 times 1, right? After 1 times 1, then the result, we want to add that to this term. -2 plus 1, that's going to give us -1. Then you take 1 again, 1 multiplied by the answer. That'll give you -1. You take that -1, and you're going to add it to the second term. Okay, because I already used number 2, or the third term, excuse me. So then -5 plus -1 is going to give me -6. And once I get that -6, I'm going to multiply it by the leading coefficient, -6. Then the final thing is to add it to the final. So -6 plus -6 is going to. So the bottom row is, we have 1, -2, -5, and 6. The bottom row is going to be 1, -1, -6, 0. Okay, and we established that here. That, 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 that. Okay, or I guess a different way to look at it would be 1, then -1, -6, 0. Either way, you can pretty much interpret it from that. So the quotient is x squared minus x minus 6. Okay. Again, there's the 1, the -1, the -6, the coefficient of. Okay. So now let's factor this quotient here. Okay, because this can be factored. Remember, you got to multiply two numbers that gives you -6 that add up to give you this. It would be x minus 3 and x plus 2. Now, now we need to include the original factor. The original factor we saw up here was x minus 1. So the final result, we have f of x equals x minus 3 and x plus 2. So the polynomial is now completely factored. Okay, so that's how you factor this particular polynomial. All right, let's move on to example number 4. Example number 4, if f of x is divided by x minus 4, give quotient x squared plus 2x minus 1, the remainder of 7, we need to write it in expanded form. So using the division relationship, we want to, so dividends equal divisor times the quotient plus the remainder. So f of x equals x minus 4, x squared plus x plus 7. Now we need to expand this, okay? So this expression here is essentially x parentheses x squared plus 2x minus 1 minus 4 parentheses x squared plus 2x minus 1. And that's divides to x cubed plus 2x squared minus x 4x minus 8x plus 4. Then we combine like terms. After combining like terms, we're going to end up with x cubed squared minus 9x plus 4. And now we add the remainder of 7 onto this. We have f of x equals minus squared plus 11. Let's look at a common mistake. A student divides by x plus 6 and places plus 6 in synthetic division. Correct the setup. So this is incorrect because synthetic division uses c from the form of um, x minus c, right? So the divisor is x plus 6 in this case, plus 6. So we need to rewrite that as x minus minus 6. Okay. So this tells us that it's essentially x minus a negative 6, right? Which is c equals negative 6. So the number placed in synthetic division should be negative 6, not positive 6. So the sign changes because x plus 6 means x minus negative 6. Okay. All right. Final review. When you use polynomial division to divide one polynomial by another, you need to be careful because synthetic division works for divisors in the form of x minus 6. Oh, excuse me, x minus c. So if you see x plus 1, then you need to change it so that it makes sense according to this form. Remainder theorem. Dividing by x minus c leaves the remainder as f of c. And then the factor theorem, you have x minus c is a factor exactly when f of c is to 0. Using synthetic division, um, we need to use synthetic division when the divisor is linear and use the remainder theorem to find remainders quickly, and then use the factor theorem to test whether something is actually a factor, right? And thank you for watching. That concludes.